Alright, number 1, you have a wave that oscillates 5 times a second with a speed of 6 meters. Now the first thing is obvious. If you have 5 oscillations in 1 second, this is actually your frequency. Now in regards of your period, you have a frequency of 5. 1 divided by 5. You have a period of 0.2 seconds for each cycle. Now in regards of wavelength, the equation is speed, frequency, wavelength. You already have the frequency of 5. You're solving for wavelength, and your speed is 6 meters each second. So you divide both sides by 5. So 6 divided by 5 equals 1.2. Your units here will be meters. Now in regards of number 2, you have a speed of 5.6 meters a second, and you're given a distance of 2.4 meters from each crest to throw. Now first things first, the distance between a crest and a throw is half of your wavelength. So 2.4 times 2 is 4.8. This is your lambda or wavelength. Now the question is asking for frequency. Going back to the equation, speed, frequency, lambda. Your lambda being 4.8. Speed 5.6 equals frequency. Divide both sides by 4.8. So 5.6 divided by 4.8 equals 1.16. And these will be in hertz. Number 3, we have a frequency of 2.5, speed 1.5 meters a second. Letter A is asking for the period. Your period would be 1 divided by 2.5. So your period is 0.4 seconds for each cycle. Now, in regards to the wavelength, you have speed, frequency, lambda. Your speed is 1.5, frequency is 2.5, wavelength unknown. As before, divide both sides by 2.5. So 1.5 divided by 2.5, your wavelength equals 0.6 meters. Now, for a linear density of 2.5 kilograms for each meter, tension 30 newtons, frequency of 4 hertz. 4a is asking for the speed of the wave. Equation given before was speed equals square root force of tension divided by linear density. Your tension is 30. Your linear density is 2.5. So 30 divided by 2.5 is 12. You square root this. 3.46 is your speed. This is also in meters each second. Now, in regards of 4b, you're looking for the wavelength of the resultant wave. You have speed. You have frequency. You're missing wavelength. Now, 3.46 equals a frequency of 4 hertz times lambda. Your lambda here will be 0.865 meters. Now, as I said in class, number 5 will be omitted. Now, moving on to number 6. You have a frequency of 4 kilohertz. Speed of 1/9 for sound. And a speed for the detector of 1/9 for the speed of sound. First things first, in regards of the 1/9, 1/9 times 343. Your given speed is 38.1 meters each second. Your hertz. This is a kilo. So 4 times 1,000 hertz for each kilo gives you a total of 4,000 hertz. Question is phrased that the detector is moving towards the source. So you have static Doppler. Considering the fact you're moving towards the source, it will be a positive. Now, 6A is asking for your relative frequency received by the detector. Fs equals your source of 4,000 parentheses 1 plus your speed of the source is going 38.1 meters a second. Your speed of sound is the same. Now both of these will obviously equal the same number, so 1. Now 1 plus 1 is 2. 2 times 4,000 gives you 8,000 hertz. Now in regards to the last question, your source is moving away from the detector. So we switch from static to dynamic. Now since you're moving away, it is considered to be a plus. Now the frequency for your source was 4,000 hertz divided by 1 plus your speed of the object or your source divided by the speed of sound of the waves coming from the source, which were given to be the same thing of 38.1. Now these two numbers as before become 1. Now 4,000 divided by 2 gives you a relative frequency of 2,000 hertz. This will be your dynamic Doppler frequency relative to the observer, which in this case is the radar detector. Now in regard to the test, keep in mind you have definitions, crests, amplitudes, and the list keeps going and on. Bear in mind that you have the beat frequency, which is based off the difference of absolute. Now this can be plus, minus, depending on the question is phrased and applied. Another thing also may be minor, and I do mean minor, trigonometry. So you may need to use a few formulas relative to triangles, most likely right angles. And of course here we're talking about Pythagorean theorem. You were taught a square b square equals c square. I've taught it pretty much a square plus b square under a square root sign equals c. It's the same thing, but you skip one step by completing both of them underneath the square root. Keep in mind that your sound intensity will most likely be from point of source. This is where I equals power over 4 pi r squared. Now I want to stress this point out. Depending on your source, keep in mind sound waves propagate radially. Now, as I said before, this could be a little stick figure bird. And then you have on the outside a person. Now, the distance between the person and the bird is your r. Now, the further away from the bird, the less intense the sound will be heard. Now, as I said in class, questions focus mostly on beats. The open-ended will contain Doppler. If you use note cards, make sure I check them beforehand. Otherwise, there's a chance that you could be considered to be cheating. Good luck.